Welcome to myprojectbazaar.com. Here we are going to discuss about data core based fuzzy min-max neural network for pattern classification. Pattern classification. Pattern classification based upon the fuzzy set theory is important in the renewable energy systems. The data core fuzzy min-max neural classification is proposed in this system. The fuzzy min-max neural network based on the data core, a new membership function for classifying the neuron is discussed in this chapter. The geometric center of hyperbox creation using data core is considered. Instead of using contraction process, some kind of overlapped neuron with a new membership function based on the data core is proposed. Some algorithms of online classification presented, such as scaled gradient method, neurofuzzy classification scaled gradient method. Based upon the assigning power values and gradient values, the classification of network is carried out. The performance of data core fuzzy min-max neural network is checked by some benchmark data sets called iris data sets and compared with the traditional model. The performance evaluation of fuzzy min-max neural network and the data core fuzzy min-max network also carried out. All the results that indicates that performance of data core fuzzy min-max neural network is efficient classification and also efficient pattern recognition with weighted functions. So DCFMN has strong robustness and high accuracy in classification of some data sequence. The data sequences are used and the benchmark data sets are created. Finally, the fuzzy based classification is proposed and the performance is evaluated with the fuzzy min-max network. The flow diagram of our proposed system, it comprises four major blocks: the data sequence input and classifier without power values, and the classification with the power values, and the selected feature classification. This classification is done using the scaled gradient method and neurofuzzy scaled gradient methods. Initially, the iris data sequence data sets are taken. From this data sets, we can pass the feature values to the classifier. Fuzzy min-max neural network, by assigning the gradient value, what are all the min terms are classified and the max terms are classified without power values. After that, the power values are assigned to each data sets. From these power values, we can get the modified features. From that features, we can obtain the fuzzy min-max classification using the scale gradient method. After the classification, the performance evaluation is also mentioned to compare the existing fuzzy min-max neural network classification with the data core fuzzy min-max network. The data core based fuzzy min-max network provide the improvised classification and pattern recognition. The complexity of the system, that is classification, is reduced. And also the membership function formulation consider the overlapping sequences also. Using this type of membership function, we can classify the patterns using the data core based model. The membership function design based on the geometric center and the hyperbox creation. Using this hyperbox shed, less computation during the pattern classification is achieved using this set. Next, we are going to discuss about the running procedure of our proposed system. It consists of main function, membership function, neurofuzzy classifier function, scaled conjugate gradient method, and speed up classification, and the power value neurofuzzy classification with the scale conjugate gradient method. So our main function, it comprises the fuzzy neural network formation. The iris data sequences are given to this main function, and the subfunctions are called in the main function. After the subfunction calling, the parameters of fuzzy matrix creation and the performance value, root mean square error value are returned to the main function. In general, the creation of fuzzy min-max neural network is based upon the neural network classification input, the iris data classification, feature selection, classification with the selected architecture or the important process. The DCFMN architecture consists of 3 layers: input layer, middle layer and output layer. The number of nodes is equal to the dimension of the input data. The membership function formation is the represents the noise and the difference between the hyperbox sets, and the overlapping neural network sequences presents the membership functions, which represents the minimum and maximum value of overlapped area. The weights between the input layer and the middle layer is calculated using the scaled conjugate gradient method. Finally, the assigning of power values to the each data sets. From these power values, we can speed up the classification by utilizing the proper fuzzy min-max rule basis. The Sugino type rule bases are used to pattern the min and max network classification here. Now I run the main file. This plot shows the rule viewer of Sugino type function. Here the input values are set it as here 60.5, 30.5, 39. The low and middle and maximum values are calculated using these type of input. These inputs presents the output points here. So this output shows how the classification has to be carried out in this process. And this classification is based upon the pattern with power values. And this is the objective function value. When the iteration count increases, the objective function value which minimized to the value. This minimization which provides the complexity reduction in DCFMN architecture. Then when the number of epochs are increased, the training error which will be minimized to a particular value. And the checking error which also minimizes when the number of epochs were performed. And the display, it shows the how the classification process starts. When the epoch number, how the epoch number is varied. The epoch number is varied between 25, 25, 25 values. The classification with the neuro fuzzy classifier is initialized here. And the epoch iteration count, when the iteration count is increased to 1 to 9 values, the corresponding objective function values are displayed here. Finally, the training root mean square error and the checking root mean square error are displayed here. How the number of nodes are traveled, that is displayed in this plot. And the total number of nonlinear parameter analyzes with the 30 classification, and the training data pairs are 75 and the checking data pairs are which is 0, and the fuzzy rules are 3. With this rule, the ANFIS based fuzzy classifier is used to classify the pattern with training, checking, and also mean square error is displayed here. Thank you.